Dear students, let us continue the series on control systems. Today we are going to see the order of a system and the related terms. So the input-output relationship of a control system can be expressed by nth order differential equation. Let us take a general differential equation, an nth order differential equation. A0 d raised to n divided by dt raised to n of p of t, that is the nth derivative here of p of t, plus a1 n minus 1th derivative, that's d raised to n minus 1 dt raised to n minus 1 of p of t, plus a2 d raised to n minus 2 divided by dt raised to n minus 1 n minus 2 of p of t plus etc. up to plus a n minus 1 into d by dt of p of t plus a n p of t is equal to b0, then the mth derivative here, d raised to m divided by dt raised to m of q of t, b1 m minus 1th derivative etc. up to bm m minus 1 d by dt of q of t plus bm q of t. You can see here there are n terms here, a0 up to an, that is n plus 1 terms are there. So the highest power here is d raised to n. Okay, nth power is here. So we can see here the p of t is the output or the response, or q of t is the input or excitation here. So the system is governed by nth order differential equation. That is why it is known as a nth order system. Now let us take the Laplace transform of the system. We can take the Laplace transform here. You can see we are taking the Laplace transform, the first term a0 d raised to n dt raised to n of p of t. So p of t Laplace transform is taken as p of s. Okay, p of t, the Laplace transform of p of t is p of s. So d raised to n dt raised to n, that is the nth derivative, that will become a0 s power n p of s. That's very simple, we all know about it. a0 s power n p of s plus a1 s power n minus 1. So here the second term is n minus 1th derivative. So it will be equal to a1 s power n minus 1 of p of s. Similarly, a2 s power n minus 2 of p of s plus etc. a minus 1 s of p of s. You can see here d by dt of p of t is s times p of s. So this will be s times p of s plus a n into p of t, derivative of p of Laplace transform of p of t is p of s. So a n p of s, the last term in the left hand side. So when we go to the right hand side, we can see here the first term is b0 s power m q of s. Okay, so b0 here d by d raised to m divided by dt raised to m q of t is so q of t Laplace transform is q of s. So d raised to m is s power m. Okay, so it's b0 s power m q of s, b1 s power m minus 1 q of s plus etc. up to bm minus 1 s q of s plus bm q of s. So here in the left hand side, so p of s is a common term, so we can take p of s outside, and also in the right hand side q of s is a common term. Let us take q of s outside. Okay, so when we are taking the p of s and q of s outside, what we are getting? So in the left hand side p of s is taken outside, so what remains there? a0 s power n, a1 s power n minus 1, a2 s power n minus 2 plus etc. an minus 1 s plus an. So an minus 1 s plus an. Here p of s is gone outside here. Now q of s is a common term in the right hand side. So q of s is taken outside. b0 s power m. You can see the first term. b0 s power m. b1 s power m minus 1 plus etc. bm minus 1 s plus bm. So now we are getting the transfer function T of s, that is output divided by input, that's P of s divided by Q of s. P of s divided by Q of s. Okay, Q of s goes to the denominator from the right hand side. Now in the right hand side we can see this term remaining b0 s power m up to bm. So that is divided by this term from the left hand side. It goes to the denominator here from a0 s power m to an. So that is the transfer function of the system. So we can see the numerator is P of s, or P of s is a numerator polynomial, and denominator Q of s, that is Q of s is the denominator polynomial. So we can see the order of the system is given by the maximum power of s in the denominator polynomial Q of s. So the order of the system is given by the maximum power of s in the denominator. So here the maximum power of s in the denominator is what? S power n. Okay, so s power n is the maximum power. So n is the maximum power here. N is the maximum power. So its order will be n. So the order of the system will be equal to n. So the order from the transfer function is we have to look at the denominator polynomial and find the maximum power of s. So the maximum power of s in the denominator is the order of the system, that is from the transfer function. So we can see here the denominator polynomial Q of s, that is given by a0 s power m plus a1 s power n minus 1 etc. up to an minus 1s plus an. Okay, so that means that n is the order of the system here. So when n is equal to 0, the system is 0 order system. If n is equal to 1, then the system is a first order system. For example, n equal to 1 means a1s plus say a0, a1s plus a0. So a1 s power 1. Okay, so n equal to 1. N equal to 2 means a second order system. For example, a2 s square plus a1s plus a0. So a system like this, or a polynomial like this, that indicates a second order system. So now let us factorize the numerator and the denominator polynomial. So if you are factorizing the numerator polynomial, so we will be getting factors, first order factors, s plus z1, s plus z2, s plus z3, etc. up to s plus zdm. S plus z1 into s plus z2 into s plus z3, etc. into s plus zdm. And the denominator factorizing s plus p1, s plus p2 into s plus p3 into s plus pn. Well, here the roots here of the numerator z1, z2, z3 up to zdm are the zeros of the system, and the roots of the denominator p1, p2, p3, etc. up to pn are the poles of the system. So the roots of the numerator polynomial are called the zeros of the system. The roots of the denominator polynomial are called the poles of the system. So the order of the system n means the number of poles in the transfer function. So order of the system is also equal to the number of poles in the transfer function. So when s takes the value of s0, t of s equal to 0, and when s takes the value of a pole, then t of s becomes infinity. We all know about it from the concept of poles and zeros. So that means when s is, suppose this s equal to the pole here is what is p1. Okay, so when s is taking the value of a pole, then that is minus p1. So is minus p1 means what? Minus p1 plus p1, that is becomes 0. So 1 by 0, that is equal to infinity. Okay, t of s becomes infinity then. So when s takes the value of a 0, then t of s is equal to 0. So s is taking the value of a 0, So then this factor will become 0. So that 0 multiplied by other factors, that will be equal to 0. The numerator equal to 0 means t of s equal to 0. Okay. So when s takes the value of a 0, t of s becomes 0. When s takes the value of a pole, then t of s becomes infinity. So that is the concept of poles and zeros. So the order of the system will be, or the number of poles of the system will be equal to the order of the system. Order of the system is the highest power of S in the denominator polynomial. Thank you.